Ever wondered how a building can stand strong for decades while others crumble down? How come skyscrapers do not collapse under their own weight? Does structural design really matter in architecture? We are art quaternary, and today we will talk about the basic structural components in today's book, How Not Behold, the structural integrity behind the architectural ingenuity. Well, then brace yourselves, because we're gonna break it all down. Let's first talk about the basic components of structural design, consisting of the load analysis, the structural analysis, the key elements, and the design specifications. The load analysis pertains to the forces that act upon an object. Meanwhile, we have the structural analysis, which is the response of the object to those forces. The key elements of the structural design pertain to the foundation of the building under the floors, the columns, the beams, the slabs found within the section of the building, and the trusses and the framing systems on the upper floors, which would make the roof. Now we have the detailed specification, which pertain to the design considerations of the components, such as the material and the dimension used for the object.
When we talk about strong and long lasting buildings, we often think of concrete. But concrete alone isn't enough, it needs reinforcement. Concrete is great in compression, but weak in tension, meaning it can handle heavy loads pressing down on it but struggles when pulled apart. That's where reinforcement bars or rebars come in. They help resist tension, forces, and improve the overall strength of the structure.
Let's start with the backbone of the building, the beams and columns. Beams are the horizontal components of the building that supports the upper floors and the roof. They distribute the loads and lead them to the columns. Here's the example of the beams. On the other hand, columns are the vertical components of the building that supports the beams and transfer the load to its foundation. And foundations of the buildings are actually found underground. So the load will disseminate to the soil and the structure withstands the pressure with the accuracy of calculations. Together, they form the skeleton of the building with framing system and trusses. But without these two elements, the buildings wouldn't stand at all. Let's imagine a Jenga. If there is no balance between the horizontal and vertical blocks, the tower will crumble down. And here's the example of a column. Eliza, in regards to this, is it a two-way or one-way slab?
It might be either. Like a wide beam, one way slab have support on two sides and bend only in one direction.
Two-way as well?
Two way is bending in both ways and on all four sides. Supports and spans ratios determine this. Even with four supports, it behaves like a one way slab. If the long span is at least twice as long as the short span.
Okay, so it concerns the shape and how they are supported.
Absolutely. We design them based on how they are supported. Rectangular beams are the design of one-way slabs. The loads must be taken into account as well.
In what way?
The weight of the slab itself and whatever weight it supports. Concrete has a density of about 23.5 kilonewton per cubic meter.
Oh, okay, I understand. So we know slabs transfer their load to beams, so what happened next?
The beams distribute the load to the columns or walls, which then pass it down to the foundation. It all follows the line of gravity, ensuring a stable load transfer.
Okay, and if the structure encounters lateral forces such as wind or earthquakes?
That's where lateral supports like shear walls, brace frames, and moment frames come in. They counteract horizontal forces to keep the building stable.
Okay, got it. And beams, how do we classify them?
Based on support conditions, simply supported beam resting on both ends free to rotate, then fixed beam rigidly held at both ends preventing movement, cantilever beams fixed at one end extending freely, and lastly continuous beam extends over multiple supports reducing bending stress. And then by shape, I-beam, T-beams, rectangular beams, each designed for different load distribution.
So, the choice of beam depends on the building's need and the type of load it carries.
Exactly. A well designed structure ensures loads are efficiently transferred from slabs to beams, then to columns, and finally to the foundation.
And with accurate calculations, we can create a resilient and functional building.
Precisely. Every structural element must work together to ensure safety and efficiency.
The advantages of the structural design process include ensuring the structural stability and the safety for its occupants.
It helps optimize materials and costs,
And it also allows for energy efficiency and sustainability.
and it improves aesthetics while maintaining function.
Now for the cons of the design process. It requires extensive calculation and time and can be costly if revisions are needed.
In addition, it must balance safety and budget constraints. And lastly, unexpected challenges can arise during construction.
Every structure has its pros and cons depending on the materials and design choices.
Steel, super strong but expensive. Concrete, durable but heavy. And lastly, wood, eco-friendly but needs protection from the elements.
And let's not forget about bad design. Cut corners and your building could come crashing down.
So, a good design is not just about looking pretty, it's all about standing strong.
Still wondering how a building can still exist despite more than a decade, like Burj Khalifa? See its structural design and you'll see the level of accuracy defined on its components in order to achieve its resilience despite the site conditions in a test of time.
If architecture delves on arrangement of spaces and aesthetic of the building, structural design focuses on the framework and mobility of the structure. Together, these concepts enable the manifestation of sufficiently functional and pleasantly eye-catching buildings. For architecture to work, we need the basics of structural designs to create a feasible plan for our structures.
In structural engineering, the design delves on more complex and detailed methods to acquire the accurate and efficient application of components. So even we cannot abuse our creativity when we do not consider the feasibility of the project with the appropriate calculation necessary to have functional, safe, and humane consideration for the building. Worry not because your efforts will bear the lives of many and sustainability of the future.
And there you have it. Structural design matters a lot to architecture, and architecture complements structural design with the arrangement of spaces. Again, we are the Arquaternary, your trusted architects. We hope you learned a lot from today's vlog. Lo and behold the structural integrity behind architectural ingenuity. Thank you for watching.